Hi team, Mr. Rator here. Okay, continuing with Unit 12, Similar Shapes. Let's have a read of this question. Question 7. A, B, C, D and A, E, F, G are mathematically similar. So let's go A, B, C and D and A, E, F, G are similar. Okay, the two trapeziums here. So it gives you all the lengths of those. It's given in the diagram. It goes work at the length of AB. A to B, okay, and then it goes here, the trapezium AEFG has an area of 36 centimeters, work at the area of the shaded. Okay, so a couple of things here, that's 2 marker, and then that one is a 3 marker, as you will see later. So let's do this one first. First of all, as always, I'm trying to sketch them separately. So I'm going to draw the trapezium carefully separate to what I got here. So there's my A, there's my E, that length is 5, okay, that length is 12, which is E to F, and F to G, we haven't been given those, we don't really need them at the moment. All we need is a corresponding side to find the scale factor, so this side corresponds to the side B to C, okay, so that's gone from 12 to 18, so we need to look at the scale factor where we multiplied by, what do we multiply 12 to get to 18. So to look at the scale factor, I always do get the bigger side, longer side, 18 shared by the smaller side, which is 12, the corresponding one, and 6 into both of them is 3, 6 into 12 is 2, that is 1.5. So the multiply, as some of you might have told straight away, is 1.5. Now we have to find A to B. Okay, so I know that A to E is 5, so I need to multiply 5, so AB is going to be 5 multiplied by 1.5, okay, because that's been enlarged by scale factor 1.5. So 1 times 5 is 5, half of 5 is 2.5, 2.5 plus the 5 is 7.5. So that is the length of A to B. Now, it tells you that the smaller trapezium AEFG has an area of 36 centimeters squared. So that is the area. Now, what you should know is when we're talking about areas, the scale factor, what happens when we're dealing with area is when we're talking about length, let's just look at length here. I'm going to call that small, this is the small shape, and that is the large shape. Okay, so whatever the small shape was, this case the length, whatever the length, this was 5, this length was 5 here. The larger length was 7.5. So what we're doing is comparing the length of A to E and B to A. We could also have done 12 to 18. The key thing is the scale factor is 1.5. That shared by 7.5 shared by 5 will give me 1.5. That's the scale factor. When we're doing similar shapes and we look at area, the scale factor, this length is in centimeters. The area is measured in centimeters squared. So what happens here is you do a length times by a length. Now if one of the length was enlarged by 1.5 and the other length was also enlarged by 1.5, to get the area you're literally done 1.5 times 1.5, so you've actually got the scale factor and you squared it, so 1.5 gets squared in this case. Okay, to find the area, so 1.5 times 1.5, 15 times 15 is 225, so that will be So the area is going to be 2¼ times bigger than the area of the smaller side here. So if this is 36, the smaller, if I do 36 and multiply that by 2.25, my area for my larger trapezium is going to be 81 centimeters squared. So find the area of the shaded region, and that is the area of the larger trapezium. We've been asked to find the shaded region, so what we need to do is we need to get the 81, which is the larger trapezium, take away the smaller trapezium, which is that white area here, which is 36 centimeters squared. So we need to take 36 from the 81, and we're going to be left with the area for the shaded region is going to equal to 45 centimeters squared. This is the area of the shaded region, around 45 centimeters squared. Okay, so when we're doing this, just remember, key thing to remember is that when we're working out area, the scale factor gets squared. The scale factor gets squared, because if we got a side by a side, and this was the scale factor, the scale factor was, for instance, 2. This scale factor, this is also being times by 2. So when we find the area, the scale factor times the scale factor for the area is equal to 2 times 2, which equals 4, which is 2 squared. Okay, get squared. Okay, just remember that. And that's why we get the area for the larger one becoming 81 centimeters squared. And then we take that from the 36 to get the area 45, which is that shaded region. Okay, let's have a look at the next question. Let's clear this. Scroll down. Question number 8. Okay, now we're going to start looking at scale factor involving area and volume. Right. So let's just quickly remind ourselves what's happening with scale factor here before we start going through here. So when we're looking at let's just say we're looking at a length here. So what happens is when we first start with the length, you'll get a scale factor. Okay, so I'm going to call length, let's just call it centimeters in this case. And you get one side being enlarged by another side, we call that just a scale factor here. When we look at area, what happens is we times those two lengths together to get centimeters squared. So what happens here is the scale factor gets squared. And then when we're looking at volume, which is measured in centimeter cubed, what happens here is we do the length times length times length, and what happens to the scale factor in this case, it gets cubed. Okay, best time I remember is centimeters when you're looking at the units of measurements. If it's just centimeters, you've just got the scale factor. If it's being squared, the scale factor is being squared. And if it's looking at centimeter cubed, or meters cubed, or looking at whatever the unit is, and being cubed, then the volume gets cubed. So let's start this first of all. So you must always bring it down to length, get the scale factor of the length, then we can work out the area and volume afterwards. The diagram shows solid shapes A and B. So we've got lengths here. Okay. Now solid A has a volume of 80 centimeters cubed. Find the volume of the solid B. Okay. Now as we set this up, we'll set it up along here. I'm going to say we got we got A and we got B. Then I'm going to put my scale factor separate here. see what happens then. So my length, I'll go for the length, L for length. This is A is 4 centimeters, B is 8 centimeters. And if I do 8 shared by 4, I get a scale factor. If I do 8 divided by 4, my scale factor is 2 for the length. So already I know that if I'm looking at area, in this case I'm not looking at area, but if I was looking at area, my scale factor will be squared, which will give me 4. So my area will be 4 times, the bigger shape will be 4 times bigger than the smaller. And if I'm looking at volume, V for volume, my scale factor 2 is going to be cubed. So 2 cubed, 2 times 2 is 4, times 2 is 8. So the volume, or the bigger shape, the volume of this shape here is going to be 8 times the volume of this shape. So if it told me that this was 80, if A is 80 centimeter cubed, my volume for B is going to be 80 multiplied by 8. 8 times 8, 64. Put the 0 at the end. That will give me 640 centimeter cubed. So that will be the volume, be 640. Okay. Now, it goes here. Solid B has a total surface area of 160 centimeters squared. So I'm going to go back here. It's always important to put this just in case it comes further down in the later questions. So my surface area for B is 160 centimeters squared. Now this is area. So the scale factor for area is 4. That means my larger shape, the area for my larger shape is 4 times bigger than the area of the smaller. So when it goes here, work out the total surface area of my solid A, I'm going reverse of timesing, which is dividing. So my area of A is going to equal 160 shared by my scale factor, which is 4 in this case. If I do 4 into 16 is 4, put the 0 at the end, that will be 40 centimeters squared. So my area for the solid shape, surface area for the solid shape A is going to equal 40. Since 40 times 4 will give me 160. Okay, now this does come up quite often in the exams, so it's very important that you understand what happens to the scale factor when we just finding the normal for the length. When it's area, it's centimeters squared, so we square the scale factor. And when we're talking about volume, we're cubing, centimeter cubed, so we're cubing that's scale factor to get this. Okay, let's just clear this, scroll down further. So looks like we've got another similar question here, 9, 10. Okay, so we might as well have a look at these two, see what's happening here. Okay, actually if I pause this, save this for the next video, so I'll do those two in the next video. Let's just pause this.